mouthwashes, and that's completely legal. So you can fool the test that way. Also, sometimes after a person swallows they drink a lot, then they lose their drunkenness. It's basically out of their bloodstream, but there's still some liquid in their stomach. They can burp it out, and the burp will burp out some of the alcohol, the gaseous alcohol. That will also cause a false positive. The person might not have blood in their lungs, in their veins or in their lungs, but the detector will detect the burped out alcohol. So the tester has got to be paying attention to the subject. Can't just say, okay, here's a breath test, I'll see you in another 5 minutes. They got to actually see if any hanky-panky is going on. So as mentioned, the alcoholic beverages that might not have been swallowed, or alcoholic mouthwash, which I'm assuming people do not swallow. Not a good idea. It's not meant to be swallowed. So this will dissipate after 15 minutes. So if we know that the person just drank their scope, or they washed their mouth with scope, or some alcoholic, I don't know if scope is alcoholic, but whatever it is, some alcoholic mouthwash, you have to wait 15 minutes. Because then, after that point, everything in the mouth will be evaporating. Similarly, if you hear them burping, wait 15 minutes. And I don't know if this is a good idea if you want to, if you know your alcohol is going to die out after 45 minutes. Let's say you took a certain whatever, it'll only take you less than an hour before your alcohol content, blood alcohol content, will go below the 0.08. Just keep burping for another 40 minutes or so, and by the time they test you, it'll all be gone. I don't know if that's a reasonable thing to do, but in theory, they've got to test you only 15 minutes after the last belch. Okay, let's move on. I'm getting a little gross here. So anyway, the truth is, it's better to do more than just one test. Do 2 tests to ensure that the device is still working correctly. If it's done twice with the same result, you can assume that everything's fine. So it's best to do more than just one test. So how do these devices work? I mean, you're breathing into it. You're taking your mouth, you're blowing into it, and you're breathing into it for a few minutes. How does it detect anything? Well, we mentioned spectroscopy for spectroscopy. We also mentioned that IR, infrared spectroscopy, can tell you exactly what the compound is that is being sampled. You have an infrared beam. It goes through this air that you're breathing out, and it sees what gets absorbed, and whatever gets absorbed, it can tell, it gets a signal by what gets absorbed, what is in the air. So if it detects alcohol, it knows that there's alcohol. And the more it detects, the more alcohol is in the breath. And there's a way to relate the alcohol in the breath to alcohol in the blood. We're not going to talk about that. It's a simple formula, but we're not going to talk about it. The point is that, it's done by the device itself, so people don't have to actually calculate it. So the idea is you breathe, the air goes through an infrared beam. The infrared beam's absorption is noted, is detected, is identified. From there, we know that there is alcohol and how much alcohol is in there. There may be some interference, like acetones. We have another beam to test for acetone in case there's acetone in the breath. I mean, don't ask me why a person would have ingested acetone, but in case there is, we have another detector that tests for acetone to know that there is an interferent here. I really don't know how often people drink acetone. It's a poison. It's what they find in nail polish remover. I don't know why people will be drinking it, but if it causes some kind of interference or some other interferent that might actually be edible, we will know because we have another beam to test for these interference. Okay, that's how one device works. Very simple. You breathe, beam goes through it, test the beam, see what the beam tells you. That'll tell you if there's alcohol and how much. From there, we find what the blood alcohol content is. If it's above 0.08 or below, or whatever you might want to test for. The other way, the smaller ones, these are often used more in the field because they're smaller and they're easier to carry around. Although both are, they're both sized enough for field work. Anyway, the fuel cell ones are generally smaller. They work on a chemical reaction. Here's the alcohol over here. In water, if it's together with oxygen, if you can it produces this thing, that's acetic acid, and it will give off 4 of these hydrogen ions as well as electrons. We'll think about electrons later, but it'll give off these 4 hydrogen hydrogen ions, cations, if these things will get pulled away. This will happen very readily. Now, if you have a membrane that'll carry it to the other part, which has oxygen, and that's what this is, it takes these 4 hydrogen ions, combines with oxygen, it works very readily to form water. Water is very stable, so this happens very readily. All you have to do is make sure these hydrogen cations get absorbed, get to the oxygen. You have to get there, and then this thing will produce naturally, and these electrons will also be produced. You harness these electrons by putting it through a detector, you'll know the electrical current that's produced. The more the alcohol you have, the more the electrons you will have, and therefore the more of a signal, the more your detector will detect your alcohol. So you breathe this into a fuel, that's called a fuel cell. Fuel cells, incidentally, are used to produce electricity. You have one chemical going in one end, or 2 different chemicals going in one end. You have another chemical going on the other end, and this will naturally produce electricity. So there is it's a way of producing electricity. I mean, the space shuttle, they used to use it, but it's a way of doing it. We're not going to go into that, but the point is that's why it's called the fuel cell, because you take your alcohol, your oxygen goes in one end, and outside the other end goes your acetic acid and your water. Harmless stuff. But the point is that it works and produces electricity. The more alcohol, the more electricity. The higher your blood alcohol content, the more alcohol it will find, and therefore the higher the electricity, the higher the signal. So your signal will tell you how much alcohol you actually have in your breath. So that's what this is, that's what it detects. The electricity goes up, it means your blood alcohol is higher, and it'll know how much is in the air. Your alveolar air, in the air from your lungs, and therefore how much is in your bloodstream. And you can tell what the blood alcohol content is from that. So, the thing is, we really want to know, technically, we don't care about how much alcohol is in the blood. We care about how much alcohol has affected the brain. So all this has been testing the alcohol that's maybe in the bloodstream. But in order to get the brain, we have to actually dissect the brain, which we can't do on a live person. Again, this is good. It's actually good enough to see, okay, the blood alcohol content is 0.1. That's too high. He's impaired. But it's not necessarily true. Number one of the things that the lawyers fight about is the fact that you're testing the breath. The lungs get alcohol before the brain. It's possible the person had alcohol in his breath, but not much got to his brain. The person was absolutely not impaired. So it's really okay to be driving with when your lungs test for have past 0.08. Because the brain is not affected. The person is perfectly capable of driving and making decisions and driving safely. So this is actually lawyers know how to argue the case. So make sure when it's tested right. You test over some time. Don't just do a quick test. You should find out when they drank last. So you know that, it might be in the lungs, but we're pretty sure it reached the brain by after, let's say, 20 minutes. Anyway, the idea is the alcohol gets to the lungs before it gets to the brain, and this is argued by lawyers that the person was actually not impaired. We really want to know, was the brain affected by the alcohol? Even if we know how much alcohol was in the blood, we know what the blood alcohol content is, we know how much we get from the breathing.